Good morning, student. From today, we are going to start a new chapter from Physical Chemistry, class 12, and the name of the chapter is Chemical Kinetics. Now, first of all, try to understand what is chemical kinetics. It is the branch of chemistry in which we study about the rate of chemical reaction. In general, we can understand rate of chemical reaction simply means how much time is needed to complete the reaction, or simply you can say that what is the speed of the reaction. On the basis of rate of reaction, chemical reactions are classified into three parts: slow reaction, fast reaction, and moderate reaction. Now, what are slow reaction? These are the reaction which occurs with very slow rate and takes lots of time to complete the reaction, like rusting of iron. Similarly, fast reaction are those which occurs very readily, like burning of magnesium ribbon, and moderate reactions are those which are neither too fast nor too slow. Now, let us consider a simple general chemical reaction that you can see on your screen. A transformed into B. A is the reactant and B is the product. And rate of reaction simply consider as change in concentration of the reactant with respect to change in concentration of reactant and product with respect to change in time. So when we talk about large change in concentration of the reactant and product with respect to large change in time, then we have minus del concentration of A by del T equal to plus del concentration of B by del T. Here you can see that the negative sign shows the decrease in the concentration of the reactant is taking place, and positive sign shows increase in the concentration of product is taking place. And this is for large change, and that's why it is known as average rate of reaction. This is called average rate of reaction. Negative sign is the indication of decrease in the concentration of the reactant, and positive sign indication of increase in the concentration of product. And this large change in concentration of the reactant and product is said to be as average rate of reaction. This is called average rate of reaction. Now, what happened? Watch carefully on your screen. If we observe that as soon as time get changes, there is change in the concentration of the reactant, or small change in the concentration of the reactant and product with respect to small change in time, said to be as instantaneous rate. R equal to minus D concentration of A by dt equal to plus D concentration of B by dt. This is called instantaneous rate. This is instantaneous rate. Again, negative sign indicates decrease in the concentration, and positive sign indicates increase in the concentration of what product. In other words, rate of reaction is also defined as disappearance in the concentration of reactant will be equal to appearance in the concentration of product. So both type of rate of reaction is clear to all of you. Move on to the next part of this particular class. Apply the rate law for the given general reaction. A general reaction is taken, as you can see on your screen, AA, BB, CC, DD, where small a, small v, small c, and small d are the coefficient of reactant and product, and capital A and capital A, B, C, and D are the representation of reactant and product. So when we apply the rate law, what we need to do, all the coefficient has to be expressed in fractional form and all are in the equal form. Negative sign is placed before change in the concentration of reactant and positive sign placed before change in the concentration of product with respect to time. So R equal to minus 1 by A del concentration of A by del T equal to minus 1 by V del concentration of B by del T equal to plus 1 by C del concentration of C by del T equal to plus 1 by D del concentration of D by del T. This is the rate law, and this can be more clearly understandable by taking an example. Formation of ammonia, nitrogen plus 3 molecule of hydrogen results the formation of 2 molecule of ammonia. So rate R equal to minus del N2 by del T, because there is coefficient is 1, nothing means 1 is the coefficient, equal to, in case of hydrogen coefficient is 3, so minus 1 by 3 del H2 by del T equal to plus 1 by 2 del NH3 by del T, because the coefficient of ammonia is 2. So this is the application of rate law for any reaction, and this one representation in the average rate, and this is instantaneous rate. So it is very easily understandable. And rate of reaction, therefore we can write like this: change in the concentration of reactant or product with respect to time. An SI unit of concentration is mole per liter, and for time it is second. So mole liter inverse, second inverse is the unit for rate of reaction. So up to this, if you have any kind of problem, then you can make your doubts in comment box. And tomorrow in the next class we'll discuss some more important topic related to the chemical kinetics.